Hi, my name is Joshua from tagg and welcome back once again to my channel. In today's video, we would learn much on matrices and some basic matrix operation in R. In our last video, where I talked extensively on the concept of data types in R, we established the fact that matrix algebra is one very important thing even in most data science techniques and approach. I give an instance, I give an example of how important it is even in most regression and classification techniques. So today we're going to learn how to create a simple matrix and then perform some basic matrix operations. So the first matrix we're going to create, I will call it matrix A, and then I use the assignment operator. To create a matrix in R, all you need to do is to say matrix. It's a function from the base package, and then you put in the vector you want to use in creating the matrix. So the vector I'm using is just vector storing numbers from 1 to 4, and the dimension of the matrix is matrix that has 2 rows and 2 columns. So this kind of matrix is called a square matrix. So when I run this, Control plus Enter, on the global environment, I have my matrix. So I can print it out by just pressing A and then Control Enter. Then I have my matrix of the dimension 2 by 2. So you can check the dimension of the matrix by using the function dim from the base package, and then you put as an argument the matrix, the variable storing the matrix, which is A in our case. So you run this, and then you have the dimension of the matrix to be 2 by 2. So again, I'm going to create another matrix and I'm going to store it in a variable called B, and then the same way I'm going to say matrix, and then this time around I'm creating a vector and I want to use 5 to 8. I'm also creating a square matrix, that's 2 by 2, and then I run this. So a matrix object B is created on the global environment. So like I said, we have a square matrix. So the square matrix are matrices that have the same row and the same column. That's what we call a square matrix. So I've created a matrix called A and another one called B. So I'm going to create another matrix again that is quite different from what we have with A and B as square matrix. So I will say matrix, and then in this case I am using the vector I'm using is number ranging from 1 to 6, and then I want it to be 2 rows and 3 columns. So when I run this, I also have my C created. So this matrix is the matrix that is of the dimension 2 by 3. So it is also possible I create a null matrix. A null matrix is a matrix that has no elements in it. So I could easily do that by saying D is a null matrix, and then I'm still going to use the function matrix from the base package, but in this case I'm going to say numeric, and then I'm creating like 4 empty objects, and then I said let it be a square matrix, and then I run this. So if I print D, or by just pressing D alone, if I print D, then look at what I'm going to have. I'm going to have a matrix that has no elements. So this is an example of a null matrix. So this is an example of a null matrix. So it is also possible for us, let's talk about diagonal, because these are some simple terminologies that we need to understand. So when you talk of diagonal, it's just like a line, a perpendicular line, like a perpendicular line that is slanted from probably the top down to the bottom. For instance, I'm going to do an example. I'll say diagonal. This is a function again from the base package. It helps us to extract or replace the diagonal of a matrix or construct a diagonal matrix. So in this case, what I want to do is not to extract or do anything. What I want to do is to create a diagonal matrix. And then I'm going to say diagonal matrix and I put 4. So when I run this, look at what is going to happen. So it creates a square matrix for me that is of 4 dimensions, 4 by 4, and then if you look at the places where we have 1, 1, 1, 1. So that particular place are what we call the diagonal of a matrix. So if I say diagonal, let's see what will happen. Diag, and then from the base package I put 3. Let me bring it down. You see the places where we have 1 indicates the line of the diagonal, indicates the diagonal. So we have created the matrix A. It is also possible this is A, for instance. The diagonal is just 1 and 4. So for me to print out the diagonal, I can say diag, and then I say diagonal of A. And then if I run this, you see the result as 1 and 4. So let's just do like some basic matrix operation. The first we're going to do is addition, subtraction, division, multiplication of matrix. And so one of the conditions that must be fulfilled for you to like add matrices together is that they must be of the same dimension. So I created intentionally A that is of dimension 2 by 2 and B that is also a square matrix of the dimension 2 by 2. So it is possible for me to add those matrices together. So what I will do is to say A, very simple, plus B. So in this case, you have the understanding that A is not just the letter of the alphabet. A is a variable storing the matrix that has values 1, 2, 3, 4 as the vector we use in creating them. So if I run this, you see what we have: 6, 10, 8, and 12. This is just like a column-wise addition. So if you see A, the values we have in here are just 1. Let's print out B again. So the first element is 1. 1 plus 5. 1 plus 5 is what gives us 6. Let's check the element that we have here. This is 2. 2 plus 6 is what gives us this 8. Let's see how we got 10. The third element here, which is in row 1, column 2, is 3. And 3 plus 7 gives us 10. The next is 8 plus 4, which gives us 12. So this tells us how to perform some simple operations with matrices that are of the same dimension. So you can also say A minus B, and it also follows the same column-wise subtraction. You can say A divided by B. It also follows the same. You can as well say A raised to the power of B. It also follows that same column-wise power procedure. So at the same time, you can say A times B, A times B, and then it also performs like a column-wise multiplication. It performs a column-wise multiplication for us. So now let's talk about like matrix multiplication, not the column-wise. Let's say matrix multiplication. And so when you look at this particular thing, one of the conditions that must be fulfilled with matrix multiplication is that the column of the first matrix you want to multiply must be the same with the row of the other matrix. And so the resulting matrix that you will form by the multiplication of these two matrices would now be, the dimension will now be the row of the first matrix multiplied with it by the column. That will be the combination that we'll have in the end. So we're going to do an example. We have a matrix A created already, and the dimension, this is the dimension of A. The dimension of A is 2 by 2, and we also created the matrix C. Let's see the dimension of C. So if you check, you would see that the column, dimension of A is row 2, column 2, and the dimension of C is 2 rows, 3 columns. Now the column of the first matrix is 2. Now the row of the second matrix we want to multiply with it is 2. So this fulfills that particular condition before we can go ahead to do the multiplication. And so the resulting matrix we're going to get is going to be of dimension 2 by 3. We're going to see an example. But before I do that, I'm going to create another matrix again. I'll say E. So I'm going to say matrix, and then I'm using 1 to 6 again as I have it in C, and then I'm going to say instead of 2 by 3 I'm going to say 3 by 2, and then I run this. So let's just do the multiplication, the matrix multiplication. So the way to multiply matrix in R is very simple. You are not going to use these times alone. This is just like I said earlier, it is like a column wise multiplication. So for you to multiply matrix in R, you are just going to use this percent multiply by percent, and then you see by the new one we just created, E. So if you run this, there is going to be an error, non-conformable arguments. That is, A and E do not conform with the kind of convention. It do not conforms with the condition. The conditions for the multiplication is not fulfilled, because if you check the dimension of E, like I said earlier, you see the column is 2, right? The row is 3. Let's check 3, and then the dimension here for A, if you see it, and so we're going to have like something quite different. We're going to have something quite different. So if I do the dimension of C, and then we have it. So you could see the column is 2, the row is 2. So that particular condition must be fulfilled. And then if it is easy for me, it will be easy for me to just say this by C, and then when I multiply, like I told us, the resulting matrix is going to be matrix of the dimension 2 by 3, 2 rows and 3 columns. So this is the way it is when you are trying to like multiply matrix together. So I'm going to, no, before I stop, I won't stop at this point. I will say something about this function cross prod, and then in the other part of the video, the concluding part, I'll talk about some other basic things again that we need to understand when talking of a matrix. So I say cross prod. So if I use this function cross prod, and I say cross prod A and C, and then if I run this, the result is quite different from what we have in line 32. What does this mean? So this result we see here, it's simple. What we are doing is we are taking the transpose of A. So I wish I could draw a diagram and explain this concept of transpose for us, but don't worry, in the second part of the video I'll start from this concept of transpose. What we are doing is to say transpose of A multiplied percent by C. So if you run this, you would still have the same thing as 5, 11, 17, 11, 25 and 39. So these are some of the basic matrix operations that we can do using R. And with the understanding of some of these things, the concept of machine learning, regression and classification techniques will become very easy for us to understand. And it doesn't mean the kind of background we are coming from, whether you did art, sciences or any kind of a thing. These things are what we can learn and get better at. So thank you very much for choosing to learn R with me. I want to wish every one of us a Merry Christmas in advance, and I pray that God himself will give us a Christmas gift. So have a great day. If you are yet to subscribe to this channel, please, before you leave, just hit the subscribe button and also share with your colleagues. Thank you very much. God bless you. Bye bye.